Hey Kata, wanna be a const expert?
Yes, but how?
By taking a quiz.
Ok, ma che quiz?
Let's start from the beginning.
Okay, here we are. Very nice. But to better engage our friends, what if we let them take the quiz first and then we review it late together?
Okay, folks, here on the screen or down in the description, you will find a link to take the quiz.
Ok, ma che quiz?
The quiz. Pause the video and come back when you're done. Hey! How did it go? Leave a comment down below with your score.
Okay, let's do it together.
Yeah, let's do it.
Remember, comment.
Let's start. Okay, what does
Okay,
const mean in this context? Yeah, it just means that foo cannot be mutated. Foo is a const.
okay,
What does
easy.
const mean in this context?
This one.
Yes, I mean, you don't know if foo it's referencing a constant or not, you just know that you cannot mutate with it.
Yeah. Whoa, how many responses are there? One, two, three, four. Okay. I think that's one. Okay. Then no. And I think that.
Yeah, I mean, it can effectively be almost anything. It can be a variable, it can be a constant, it can be another reference, it can be a reference to a variable reference to a constant, an R value reference to a temporary, const R value reference, even if you can find one. It can be an object, it can be implicitly converted to foo, but I mean, at that point, it's still a temporary, so it's an R value reference at that point. But it cannot be a pointer because, I mean, pointer can be null and there is no implicit conversion there. And it cannot be something that needs to be explicitly converted because, I mean, at that point you need to explicitly do it. What about here?
Okay.
We are talking about pointers.
This one.
Yeah, this is a pointer to a const. So again, you don't know if you're pointing to an actual const or to a mutable object. You just know that you cannot mutate what you're pointing at through the pointer, but you can change the object that you are pointing to. So you can just change which object foo is pointing, but you cannot change the object that is being pointed to. What about
Okay.
this? I mean, it
Then
just
this
moved it.
one.
Yeah, I mean, moving it changes everything here. I mean, before it was a mutable pointer to a const. Now it's a constant pointer to a mutable foo, because at this point, you can mutate what you're pointing, but you cannot change the object that is being pointed. So you can do whatever you want with the foo that you are pointing, but you cannot change it.
Yeah.
Oh, multiple const.
And a real. Okay, but this is. This true. This is a real all the current answer. Yeah.
Yeah, I
Not
mean,
like the previous one.
this is both cases. This is a non-mutable, sorry, it's a const pointer, a non-mutable pointer to a non-mutable foo. Again, you don't know if you're pointing to something that can be mutated or not, but you cannot change also the object that you're pointing. So, similarly, what can be?
Okay. Yeah,
I mean,
it's true.
yeah, it's just these two. You cannot convert automatically other stuff. You can just get pointers. And in specific case, this is a pointer to a const, so it can either be a pointer to a const or to an unknown const. And all the others, I mean, there is no implicit conversion there.
Yeah.
What about this one?
Then we have this one.
Yeah, I mean, it's the same case as before. It's just that it needs to be a const now. Wait, no, sorry, it needs to be a known const now, because if you're trying to assign a a pointer to const, I mean, this is pointing to a non-const, so it needs to be mutable.
Yep.
Let's move to
And
functions.
then foo cannot be used in the body of do something.
Yeah, I mean, again, it is similar to what we said before. You don't know what it's being referenced. You just know that you cannot mutate it. What about this one?
And then I want to say nothing.
Yeah, this is a declaration. So you are forward declaring something. So this makes no sense. I mean, it's valid, but interestingly, the const is ignored. The signature doesn't care about this constness. So in this case, that const is completely ignored.
Okay.
What about this?
Then we have this one,
which is
who
interesting.
can be mutated. Yep.
And
cannot be mutated, sorry.
yeah, so you are just saying that inside the function, you cannot mutate it. It's just a safety from an implementation standpoint. But from a signature perspective, this function takes a foo. That const is ignored from a signature perspective. It's just an implementation detail that you don't want the implementation to mutate the object itself.
50% I say yes.
Yeah, I mean, one overload accepts a mutable reference, and the other one takes a reference to a non-mutable object. So what the function can do is different. So they are different overloads.
And the other 50%, no.
Exactly. As we said before, const when you are passing by value has no impact on the signature. So these two functions, these two declarations, are the same function because songs is ignored, so they are effectively forward declaring the same thing.
And if the previous one is no, I think that this one is no.
Still no. I mean, in this case, your declaration and your definition needs to agree with each other. So effectively, you are declaring the overload of do something where you can pass a mutable object, and then you're implementing the one where you can pass a non-mutable object. These two are not compatible with each other. So you are declaring and defining two different functions. So if your objective was to forward declare something and have an implementation later, that doesn't work.
And we have yes.
This is interesting. As we said before, the const doesn't impact the signature. So effectively, the signature of the declaration and definition are the same. So that const in the definition is effectively just part of the implementation, and these two are compatible. This is confusing, but it makes sense once you remember constness when you're passing by value has no impact on the signature. Return values.
Okay, then the return value of foo cannot be used to mutate.
Yeah, I mean it's always the same with const references. I mean you're returning a reference to something, well, probably that outlives the function, and just you cannot mutate it. You don't know what's about it and everything.
I like to say nothing. No, it's not like that. Who knows me knows that. But the response is the return value of build foo is constant.
Yeah, I mean, this is just telling you that you're returning a const. It's not really helpful because, what you're using the value later, so you're passing at that point, you may just want to return it by value. But if you really want it to be a const, you can just mark it. Not really useful, but you can do it.
Difficult one. Let me compile in my mind and let's say syntax. I'm C++. 17. Okay, I can do that.
Yeah, this is interesting. Before C++ 17, this was an error because foo is neither movable nor copyable. And so line 13, it's wrong because you're trying to assign a const foo to a foo, which is not okay. You cannot do that. But the interesting thing here is that from C++ 17, there is what is called return value optimization, or RVO. And in that case, the compiler is required to do what's called aliasing, and we can go in detail in a different episode if you want. Leave a comment if you want to touch that topic. And TLDR, with RVO in the specs, it's allowed for a mutable foo to be aliased by a const foo return value. So weirdly, this compiles. It's confusing, I agree, but the standard folks decided that it's valid.
That. Yeah.
Next one.
And these two.
Yeah. So the const here, it's telling you that you can call this member function or method on objects that are both const and non-const. So by default, methods or member functions can be invoked only on non-const objects. If you mark this const, it applies to both.
Okay, and the same.
Yeah, this is just the same, exactly the same concept. This is just a newer syntax. The other one is the legacy syntax, the simpler one. This is the new syntax that effectively is telling you the same thing. And this is useful if you want to play with R value references, but effectively the previous one and this one are saying the exact same thing.
And okay, this one, I'm a constant. I'm not a const depending on the constness of the object.
Yeah, I mean, do something is overloaded. So when you're calling it on a mutable object, well, there is priority, and so at that point the non-const version applies because there is priority. And when you call it on a const object, at that point the first one doesn't apply because it needs to be mutable, and so you get to the second one. So yeah, you're just effectively saying that you want to behave differently depending on the constness. What about this?
And the same one.
Yeah,
it's
again,
the same concept, but
this is just the new version of the syntax that you can dust off if you want to do something advanced, but effectively this is the same code as before.
Yeah, we are at the end, last but not the least, and we say no.
Yeah, the problem here is that you're trying to mix the legacy syntax with the new one, and that's not possible. You need to
syntax error.
You need to decide on one of the two. So you either go with the legacy or you go with the new one for a specific function overload set. You cannot mix and match.
My brain compiler just crashed.
And so, drum roll.
Oh.
Woohoo!
Voila!
If you liked, if you like this episode, like, share, and subscribe.
Leave a comment if you want a similar episode on different topics.
See you next time, folks.
Bye.